Hey everyone, so today I'll be explaining to you guys the difference of rates concept, which is your application of the integration chapter. This is one of the more confusing topic and many students struggle with this, and hence this is why I'm making this video. So let's start off with difference of rates. Usually in differential equations, you would just have one kind of rate. So you just have either an inflow, a growth, or an outflow, or in other case, a decay. And just in this topic, you're actually combining both of them. So you have inflow, so we'll just call it net. You have your net inflow, or just inflow, minus outflow. You have two rates going on. So for example, you got people moving inside the country, and you also got people moving out of the country. So that's inflow minus outflow. You have two rates happening at the same time. So the easiest example, as I've explained earlier, just you got a country. Try to imagine this is Australia somehow, and yeah, you got people moving in and people moving out. So the moving inside aspect of this would be inflow, and we label that as, it depends on what the rate is. It could be dp in this case, population, dt, inflow, minus dp, dt. It's still the same rate in terms of the variable t and p, but you just have one being inflow and the other one being outflow. And it's very simple. You just have, if you want to find the net, inflow minus outflow. However, what I want to go on about is the next one. So when you have volume and concentration and mass going on. So a typical question, we'll do it over here and I'll explain it all through the way. A tank contains 20 liters of water in which 10 kilograms of salt is dissolved. Okay, so we've got 20 liters of water in a tank right here. So we've got a tank. It doesn't have to be cylindrical, it can be anything really. 20 liters of water initially, yep. And it's got 10 kilograms of salt at the start, okay. It's dissolved in there. Pure water is poured in at a rate of 2 liters per minute. So obviously this is inflow. You got right there. Okay, and here's the important part, dV dt. They did not give us the mass of salt going in. It just says pure water is poured in at a rate of 2 liters per minute. So 2 liters per minute, that means your volume over time, that is 2 liters per minute. That's your unit. Okay, mixing occurs uniformly, yup, and the water is released at 2 liters per minute. So released mean outflow, and it's just going out. Once again, dV dt, because it's talking about volume over time, 2 liters per minute. You can put a negative there, or you just have to remember it is a negative since it's outflow. Okay, the mass of salt in the tank is x kilogram right there at time t minutes, so kilograms minutes. A, construct a differential equation representing this information expressing dx dt as a function of t. Okay, so what is dx dt? We know x is the mass of salt in the tank, so mass of salt, that's x, and t is time. So the x dt would just mean the rate of inflow or outflow of salt into or out of the tank. So that's what it means. So how do you do that? Well, as we've discussed earlier, if you want to find the net flow, it's dx dt inflow minus dx dt outflow. However, unlike your problem with the population, we don't actually know what dx dt is. We don't know what inflow or outflow for dx in terms of dx dt is. We know dv dt, and that's pretty much it. So how do you get dx dt? Well, let's have a look at the inflow first. So dx dt inflow, right here. We use chain rule to help us. How do you get dx dt? Well, we know one of them, dv dt, that's 2 liters per minute. But how do you get dx dt? Simple, chain rule. The concept of chain rule. To get dx dt, you times this by dx dv, because dv cancels out and you just end up with dx dt. Okay, so now how do you get dx dv? Well, that's mass of salt over volume. So the rate of, basically another way of saying this is the concentration. So what this is it's the concentration of the solution of water flowing in. So how much salt is there in the water that's flowing in? In our example, it says pure water. So pure water meaning there's no salt in it at all. So in this case, dx dv is 0. So it's a good, I guess, a good type of question, although you should expect this in your exam or SAC as well. Pure water just means dx dv equals 0 because there's no salt in your 2 liters flowing in, so you just have 0. Okay, but what about the outflow side? Outflow, same thing, dx dt outflow. If you want to get outflow, it's pretty much your dv dt outflow multiplied by your dx dv outflow. But the problem here is, what is dx dv? Once again, that is still your concentration, but it's the concentration of the water that's getting out. There is no information here. It just says water is released at 2 liters per minute. So how do you get concentration? Is it 0? No, it's not, because there is salt inside already, and if water's going out, it should have some salt along with it. So there must be a concentration. It's not just 0. But how do you get that? Okay, so this is where you need a little bit of chemistry. Concentration is mass over volume. I know it's moles over volume, but just treat it as mass over volume, percentage mass over percentage volume. And in this case, C is your dx dv, as we've mentioned. C is concentration, or dx dv is concentration. Yep, and your mass is just x, so that's the amount of salt. So x is the mass of salt, that's it. Leave it there. At any time, at any outflow, mass is always s. It's just x. Okay, but what about the volume aspect? Okay, so if you want to get the volume, this is volume at any time t in this tank. If you want to get that, it's the initial, so initial volume, V0. I'll write out the general formula later, but it's 20, the initial, plus the inflow, so the inflow volume, 2, minus the outflow volume, 2, because we want to get volume at any time t, and you times that by t, and you get your dx dv concentration, which in this case is just x over 20. So that's it, dx dv equals x over 20. Right, so the general formula basically for dx dv outflow, just write up here, general formula for the xdv outflow is your mass. So that mass can be Q, can be anything, just whatever they give as your salt. Or actually in this case, I should call it X. Yep. So X over your V0, initial volume, plus inflow, dV dt inflow, minus your dV dt outflow. And you times that by T to get your volume at any time T. And that's it, that's your concentration formula. X over V0 plus inflow minus outflow times by T. And therefore, you end up with this diagram. If you want to construct dx dt, so the net flow, it's 2 times 0. So 2 dv dt, that's 2. dx dv inflow is 0, so 2 times 0, minus dv dt, that's 2 again, times by the xdv, which in this case is x over 20. And your final answer should just be 0 minus x over 10. Simplifies, negative x over 10, that is your dx dt, so your net flow. In this case, you actually get a net outflow of salt going out. Yeah, if you want to find x in terms of t, just use your differential equation, flip this, and integrate. And that's pretty much it, guys, for your difference of rates concept. If you have any questions, just leave a comment below and I'll get back to you. Thank you for watching this.